Oh well. Derivative. Boom. This we will fix. Oh well. Okay, so this is all our second derivative stuff. Okay. Whew. All right, so there's your first and second derivative. I hope that you paused the video when you needed a second to catch up. I'm going like as fast as possible because then I have to make less cuts in my video. YouTube only allows 15-minute videos, and I always take too long. Okay, so now we're going to talk about tangent and normal lines. Also, Gemma is asleep. And, oh, that's bright. Let's see if I can. There. Nope. And yeah, so she's asleep and she needs to stay asleep while I'm taking these notes. Okay, so tangent lines. I spent too much time talking about that. Now she's gonna wake up before I'm done. Man, now I'm making all sorts of mistakes. Okay, so we're talking about tangent lines and normal lines. All right, so lines, remember, are going to be in the form y equals mx plus b. Okay, sometimes, but as we have learned, not always, you will be given f of x and an x value. Okay, but you guys know very well from the cognitive assignment that you don't always have to do that. You find your slope. And your MT, your tangent slope, is going to be equal to f prime of x. This x comes from the x value that you're given, or you can make up an x value with letters, all right? And your m sub n, which is your normal slope, is -1 over m sub t. It's the opposite reciprocal. Okay. And your y coordinate, if it isn't given in the problem, okay, you find by doing y equals f of x, where this x, again, is the value given. Okay? All right, so that's what that is. Kinematics, our next little section. All right, so remember that S is equal to the integral of v of t with respect to t. S of t is our displacement. Okay, our v is the integral, I should have spaced this out, of acceleration with respect to t, all right? And v of t is our velocity. And remember that a of t is acceleration. Okay, so on the left, I did everything with integration all the way up. Now I'm going to go backwards. So displacement is what it is. You can get velocity by taking the derivative of displacement. And if you're given velocity, you can find the acceleration by taking the derivative of velocity or the second derivative of position. Okay, so those are the two ways you can find those. So this is with derivatives, this is with integrals. So you can go forwards and backwards. Remember, there are some key terms we need to remember. Initial is when t is equal to 0. You just sub it in. So just sub in that t, all right? That's all you're doing. At rest is a little bit more complicated. This is when velocity equals 0, and we then solve for t, and I'm going to add, so we set velocity equal to 0, we solve for t, and we sub the t back into whatever you're finding at rest. So this could be maybe acceleration or position. It could be either one. Okay. Just depends on the question. And part 2, we're going to talk about integration. Okay. So for part 2, integration. So first, we're going to talk about area. Okay, so if you have an integral from a to b of f of x dx, right, you could be asked to find the area between the curve and the x-axis, in which case you would have to either find or be given a and b, and then you're finding this area between the curve. You also could be given a function and then be given 2 arbitrary a and b's somewhere along the line, and then be asked to find the area right here. You also could, so here, let me write this down. We find a and b by solving f of x equals 0, okay? And then a and b are usually given in the problem if it's like this. Given in problem. Okay, a third thing that they may ask you to do is maybe you're given an upper function and then a lower function, and they intersect at particular x values, a and b, okay? And you're asked to find the area between these guys, okay? So remember that, like, you have your upper function area underneath that curve goes past that line all the way down. And then what you're doing is you're taking the area behind the line and subtracting that off, okay? So here we find a and b by solving f of x, so here's f of x maybe, and here's g of x, equals g of x, okay? And you'll find those a and b points. And you always take your upper and subtract your lower, right? So here we would have the integral from a to b of f of x minus g of x dx, okay? And your last application here is going to be volume. So part 2, volume. Okay, and remember that volume goes from a to b, and we have pi times our f of x squared with respect to x. Oops, that's supposed to be an x, sorry. And this is because maybe we have our function f of x like this. Okay, and maybe, let's see, maybe our a is 0 equals 0, and then our b is somewhere over here. So it's this little region right here, and we're rotating this around so that it makes this like weird vase shape. Okay, so maybe it's ugly, whatever. Okay, so maybe it comes down like this, and then we have little circles. So it's like you're stacking the circles. The integration is the stacking part, but we need to like multiply by the area of each of these individual circles. So it's kind of like taking height. It's taking the value from a to b, which is your integration, and it's multiplying it by whatever the area of this thing is. If you imagine a regular like cylinder, okay, the volume for this cylinder is height times pi r squared, where r is the radius of that circle. So we have our height, and then we have the area of this circle right here. The area of each of these individual slices or circles is going to change each time. So that's why we choose f of x as our radius. Okay, because f of x is going to define how big our radius is each way, and we have to square that and multiply by pi, and then the integration part acts as our h, or our height, okay? And that is about it for our calculus review. I hope that helped you guys understand this a little better. We're going to do a bunch of practice today. I hope that it is easier and much more straightforward. Let me know how everything is going on the discussion board. I miss you guys. I hope you're doing well. I will talk to you later, probably tomorrow. Bye.